Okay, in this video, I want to start explaining how you could do absolute value equations. Okay, so let me make sure I'm in the right color. So absolute value equations. Now, I will remind you that the absolute value will tell you the distance between that number and 0. So if you take the absolute value of, say, x equals -2, you're going to get back 2 because the distance is 2. If you take the absolute value of 2, you'll also get 2. All right. And a lot of students just memorize that it makes negative numbers positive and positive numbers stay the same. Okay, I'm going to take that away because we might need the space. But an absolute value equation, we need to do what's called take both cases. So take both cases. And what am I on about with that? I mean that the inside could have been negative, right? It could have been negative and then it made it positive. So 4x minus 7 equals 10. That'd be case 1. Or maybe it was positive and it stayed positive. Okay, let's solve both of these and hopefully we'll get a good answer out of it. So negative 4x plus 7 equals 10. I'll subtract 7 on both sides. So I get negative 4x equals 3. I can divide both sides by negative 4. I get negative 3/4. So I think that's one of the answers I want to check out. And then here I can add 7 to both sides. So I get 4x equals 17. I can divide both sides by 4. I get 17/4. Okay. So it might be worth checking both of those answers and seeing do they actually work. I have a feeling that they probably will, but let's see. So let's check. For this x equals negative 3/4, we have the absolute value of 4 times negative 3/4 plus minus 7 equals 10. And so the 4's reduce, and so you have negative 3 minus 7, that's negative 10. And yeah, the absolute value of negative 10 is 10. So that's working out. That's checked. All right, what about this one? If I plug in 17/4, does it work? Let's see. 4 times 17/4 minus 7 equals 10. Let's see. Yeah, the 4's reduce, and so you get 17 minus 7 equals 10. And yeah, the absolute value of 10 equals 10. That's working. So both of those worked. Okay, so both of those are good answers. All right, let's look at this next example. We have the absolute value of 4x minus 8 equals 12. Well, let's take both cases. I'm going to switch colors, but let's do it. So take both cases. Case A might be that, what if it was negative? What if it was negative on the inside and then the absolute value made it positive? Case B might be positive all along. So let's see what happens. Negative 4x plus 8 equals 12. Then I can subtract 8 on both sides, and that would give me 4. I can divide both sides by negative 4, and that gives me x equals negative 1. Okay, now if I add 8 to both sides, it looks like I get 4x equals 20, and then I divide both sides by 4, I get x equals 5. So I should probably check both of these and see if they work. I'm going to switch colors to signify that we are checking our work, but let's see. So check. X equals negative 1. Absolute value of 4x. Oops, not an x anymore. It's a negative 1. Minus 8. 12. So then we get negative 4 minus 8. Yeah, that's negative 12 equals 12. So the absolute value of negative 12 does equal 12. So that's true, and that's checked. What about x equals 5? Well, then I have the absolute value of 4 times 5 minus 8 equals 12. And that's going to be 20 minus 8 equals 12. Yeah, it sure does. 20 minus 8 does equal 12. So 5 is also a correct answer. So both of them worked. So that was good. All right. This next example is 6 minus r over 3, and they're an absolute value, and that is equal to 7. So let's again take both cases. Case A might be that they might have been negative on the inside. Whoops, that's not. It might be negative on the inside, and it might have made it positive. Absolute value might have made it positive. In case B, we might have that it was positive all along. R over 3 equals 7. Okay, let's see what happens. So you get negative 6 plus r over 3 equals 7. And then I can add 6 to both sides. So I get r over 3. And that is going to be 13. And now I have r over 3 equals 13. So I can just multiply by 3 on both sides. It's 39. So I believe one of the answers might be r equals 39. I'll have to come back and check. All right, for this one, well, it looks like we're going to need to subtract 6 on both sides. So I get negative r over 3 equals 1. And I can multiply both sides by 3. If I do that, I get negative r equals 3. And if I multiply both sides by negative 1, I get r equals negative 3. And so I need to check both of those to see if they work. So I'm going to check. Now, does r equals 39 work? Well, 6 minus r, it's not r anymore, it's 39 over 3 equals 7. I don't know, does that work or not? Let's see. 39 divided by 3 is 13, and then minus 6 is 7. Yes, that does indeed work. So that works. Cool. And then I can plug in r equals negative 3 and see if that works. 6 minus negative 3 over 3 equals 7. And what's going to happen is this is going to turn into negative 1 here. This turns into negative 1. So you have 6 minus 1 equals 7. And yeah, that does work. So both of those was the correct answer. All right, awesome. Let's do one more example. I think we have time for it. So let's take both cases. I have the absolute value of a plus 4 is equal to 0. Well, what if it was negative on the inside? I should switch colors back to blue. What if it was negative on the inside? So plus 4 equals 0. So negative a minus 4 equals 0. I can add 4 to both sides. Negative a equals 4. I can multiply both sides by a negative 1. I get a equals negative 4. So that's one answer I should check. Case B is what if it was positive? A plus 4 equals 0. This one's the easier one. A equals negative 4. And look at that. We got the same answer twice. So I only have to check one thing this time. Let's see what happens. Check. A equals negative 4. So negative 4 plus 4 equals 0. Yeah, sure does. So that's going to work. And we got it twice, but it worked both times, I guess. So that should be enough to get you started. I'm going to do some more examples in the next video, but that should get you started for this part.